Hi, welcome to lesson 22F, Tree Diagrams. The goal of today's lesson is to learn how effective it can be to use tree diagrams when calculating probabilities. Tree diagrams, you will find, are much more effective than grids because the two-dimensional grid is only used for determining or comparing two quantities or two events, whereas tree diagrams can illustrate spaces of possible outcomes if they're not too numerous. And then once that sample space is illustrated, the tree diagram can be used to determine those probabilities. The best way to really see the effectiveness of a tree diagram is to actually do a quick example. I know we're going to do some more examples in class tomorrow, but I'm going to do a little one right here. So suppose we got some sort of a bag, and I'm not an artist at all, so we got some sort of a cloth bag. There's a little string around it, and inside the bag that we cannot see from outside, we're going to have perhaps three marbles, three black marbles perhaps, and then we're going to have 5 white marbles. Okay, now we can't see that from the outside, but that's just for illustration purposes. So what we're going to do is we're going to randomly draw one of the marbles out of the bag and see what it is, see what color it is, and then we're going to put it back in the bag and then draw another one out. Okay, so we want to sort of draw out all the possibilities and see what the probabilities are for all those sample spaces. So we're going to set this up by saying, okay, well, here's the first draw here, and the second draw is going to be over here. The outcome is going to be listed there, and then the probability will be calculated here. Okay, so we know that when you pull draw a marble out of a bag, it's either going to be black or white. Okay, so the first draw, and I have to leave a bit of space here. So the first draw we say is going to be black, for example, or it could be white. Okay, so I'm going to draw, starting at a point, I'm going to draw branches of the tree to each of those options. So since we know that there are 3 black and 5 white marbles in the bag, that's a total of 8. So what's the probability of pulling out a black marble out of that bag? Well, from our previous work with probabilities, we see that there's 3 possibilities of getting a black ball or black marble out of the total of 8. So the probability of getting a black marble out of in the first draw is 3 out of 8. Then, of course, in contrast, if we were to choose a white marble, it would then, of course, be there's 5 possibilities of white marbles with the other 3 black there, so it's going to be 5 out of 8. So if we're pulling a marble out of the bag, we're definitely pulling the marble out of the bag, so the probability of drawing a black marble plus the probability of drawing a white marble is going to be 1, because with complete certainty we're pulling out 1 marble from the bag. Okay, so then we're going to put the marble back in the bag and draw again. So for the second draw, again, it's either going to be black or white, and then even if it were white, for the second draw is either going to be black or white. Okay, so here we'll extend the branches now. Try to make it as even as possible, and try to make it as neat as possible too to collect all the information. So again, now since we drew the black marble out, we're going to put that black marble back in here, so the probability of drawing another black marble is still the same. It's still going to be 3 out of 8. And then the probability of drawing a white marble the second time is going to be 5 out of 8 because we replaced that marble. Same thing down here. After we pull out a white marble, we're going to put it back in the bag, so the probability of withdrawing a black marble is still going to be 3 out of 8, and the probability of a white marble is going to be 5 out of 8, just like it was at the beginning, because all the marbles are back in the bag for the second draw. Okay, so the outcome here, now we follow the branches to find the outcomes. So the first outcome, we draw a black marble and then we draw another black marble, so the outcome is black and black. The second outcome is black and white. The third outcome is white and black. So these are all the different possibilities, and then the fourth outcome is white and white. Okay, so those are all the outcomes that could occur from 2 drawings of marbles with replacement when we put the marble back in again. So then we calculate the probability, and so the probability of getting 2 black marbles is 3 out of 8 multiplied by 3 out of 8, and that then gives us 9 out of 64. So we're multiplying here because when we draw the marble back out again, the fact that we got a black marble in the first place does not affect the fact that we could get a black marble in the second place, or the second drawing. So that means that these are independent events. Okay, so that's why we're going to be multiplying these probabilities together. And then for the outcome of black and white, well, we draw the black marble, which is a probability of 3 out of 8, and followed by a probability of 5 out of 8. Therefore, the probability of drawing a black marble then a white one is 15/64. And then if we get to the next outcome of white and black, the white outcome, or the outcome of, or the probability, sorry, of drawing a white marble first and then a black marble is going to be 5 out of 8 for the white marble and 3 out of 8 for the black marble, and then you get 15/64. So obviously it's going to be the same probability as black and then white, or as white and then black. And then finding the probability of drawing out 2 white marbles, we got white is 5/8, and then another white is 5/8, and then so that gives us 25/64. Now at this point it's not a bad idea just to double check that the sum of all this is going to be 64/64, which would be equal to 1. Okay, so all the probabilities must add up to 1. Okay, so we got 15, there's 30, there's 55, and 9 is 64. So 64 out of 64 is 1. So when you add up all the different possible outcomes, the probabilities will all add up to 1, because those are all the only probabilities or the outcomes that are possible. Now once you've finished drawing your tree diagram, there's often extra questions that go along with it, and you can just use the branches, the paths, and the resulting probabilities to come up with the answers. So for example, suppose we're saying, well, what's the probability of drawing 2 black marbles? Well, the probability of 2 black marbles, well, we've already calculated it. It is 9/64. So it's pretty simple just to state that 9/64 there. We could then say, well, what's the probability of drawing a, or saying if the second marble is black. Well, if we find the probability that the second marble is black, then we can say, well, here in this first path, the second marble is black. So if I'm saying, here, I'll just write this out as the probability of black and black, and then followed by, or with the other possibility of, sorry, as I'm getting all tangled here, the other possibility of a black being the second marble, is if we draw a white first and then the black. So there's the two possible outcomes where the black is the second marble. So then here, black and black is the first scenario where I have the black drawn second, and then the probability of white and then black is the other possibility when the outcome when black is the second marble. In probabilities, if we take this probability, we know that it's 9 over 64. And we take this probability, we know that is 15/64. When we want the two outcomes, we want to see, well, what's the total probability that the second marble is going to be black? What we're saying is we want to see this probability or this probability. So in math and probability, or sort of means what, when we speak in English, what and would be. So the fact that mathematically we cannot get, in two draws, we can't get two black marbles and also at the same time a white and a black, that's impossible from two draws of marbles. So in math, and means at the same time, like the intersection of the two. So both happen at the same time. So what we need here, instead of doing the and, like I've written here, that's the English and, we need the mathematical or. So it's going to be either the probability of the black followed by the black, or the probability of the white followed by the black. Those are the two situations where black is the second marble that's drawn. Okay? And so then after that, then we just have to, and or mathematically means addition when we're talking about probabilities, and we just add those together. So we get 24/64, which simplifies down to 3/8. So the probability of us drawing out a black marble on the second draw is 3 out of 8. Okay, so that's just a quick example of how to use tree diagrams. What I'd like you to do is look at examples 11 and 12 on page 586, and then take a brief look at the practice questions 1 to 8 on pages 587 to 588, and we'll continue on tomorrow in class with some examples and then time to work on those practice questions. So thank you for watching, and we'll see you in class.